Hello and welcome to the channel Beyond the Curve. And I'll be answering question number 5 of the 2024 May June FP1 paper. It says the equation 5x squared minus 4x plus 2 equals 0 has roots 1 over p and 1 over q. Without solving the equation, part 1, show that pq is 5 over 2. Okay, so part A, part 1. We need to show that PQ is 5 over 2. For that, we have to find the product of the roots. So let's say product of roots is equals to, the roots are 1 over P and 1 over Q, so we multiply both of them. And we get 1 over PQ. And the equation of the product of roots is C over A, which is directly given from the textbook. So we can also write that as C over A equals 1 over PQ. Now in an equation, a quadratic equation, the first element, this 5, will be our A, the minus 4 will be our B, and the plus 2 will be our C. So I'll jot that down, and this is A, and this is B, and this is C. I'll include the minus as well. Minus. Okay. Which means 1 over PQ is equals to C, which is 2, over A, which is 5. So 1 over PQ is equals to 2 over 5. We can take the reciprocal, which means switch the denominator and the numerator. So PQ goes up and the 1 comes down. So PQ over 1 is equals to 2 comes down, 5 goes up. So 5 over 2. Therefore, PQ is equals to 5 over 2. And that's shown. Moving on to part 2 of part A. It says determine the value of P plus Q. So in part 1 we already found the productive roots. So from part 2 we can see that we have to find the summation of the roots now. So I'll write sum of roots is equals to 1 over P plus 1 over Q. If I simplify this, we can take the LCM. So Q plus P, because we have to multiply the first root 1 over P by Q up and down. Multiply by Q, multiply by Q. The second fraction we multiply by P and multiply by P. So Q plus P over PQ. And now I can switch the numerator as P plus Q. It looks more ordered. So this is the sum of roots, but in terms of numbers, sum of roots should be found. Sum of roots is equals to minus B over A, which is also directly given from the textbook. So minus B, as we noted it down earlier, b is minus 4. So we put it within brackets, over a is 5. So that's a plus 4 over 5. So 4 over 5 is equals to, which we found earlier, p plus q over pq. Why? Because both of them are equal to sum of the roots. So p plus q over pq. And if you see this fraction, we can see that we already found the value of pq in part 1. So we can also substitute that value in. So I'll take another color. For the substitution. So 4 over 5 is equals to p plus q over pq is, as we found earlier, that's 5 over 2. Now if we have to find p plus q for part 2, then we take the 5 over 2 to the other side. So 4 over 5 gets multiplied by 5 over 2. And we see that these 5's cancel each other, and the 4 remains on the numerator and the 2 remains on the denominator, which means p plus q is equals to 4 divided by 2, which is 2. And that's our answer to part A, part 2. Moving on to part B. Hence, without finding the values of p and q, determine a quadratic equation with roots p over p squared plus 1 and q over q squared plus 1, giving your answer in the form ax squared plus bx plus c equals 0, where a, b, and c are integers. Right. So I'll mark it as part B. So in order to find the quadratic equation, we need to know the product of the roots and also the summation of the roots. So if I write this down, ax squared plus bx plus c is equals to 0. Our product of roots will be c over a, and sum of roots will be minus b over a. So we can also write the quadratic equation as x squared minus the sum, which is basically this one, the sum of the roots into x plus the product of the roots, which is this one. And this will be equals to 0, the quadratic expression. Right. So let's find the product first. Product of roots is equals to p over p squared plus 1 multiplied by q over q squared plus 1. So let's do the same thing as we did before. P times Q, PQ. Oops. Over the denominators, P squared plus 1 into Q squared plus 1. PQ, P squared plus 1 into Q squared plus 1. Let's expand the brackets. P squared into Q squared plus P squared plus Q squared plus 1. And we can further simplify this. PQ over P squared Q squared can be written as PQ whole thing squared. So it's basically this. P squared Q squared is PQ whole thing squared. So let me write that down. Plus, now we have P squared and Q squared, which are added. So let's consider the quadratic expansion of P plus Q. So if we consider this, I'll write it over here. Hopefully there's enough space. P plus Q whole thing squared. Now it's much more related to this expression, so if I expand this, it will give me P squared plus 2PQ plus Q squared. And we can see that we need, or that we already have this P squared and the Q squared already in our expression. So if we subject this P squared plus Q squared, we can see it gives us this P plus Q whole thing squared, and we subtract 2PQ from both sides. It's minus 2PQ. So instead of writing P squared plus Q squared, we can write P plus Q whole thing squared minus 2PQ. Now the reason we're writing this is because we already knew the values of P plus Q and PQ. So we write this as P plus Q whole thing squared minus 2PQ. The plus 1 stays as it is. And now we substitute in the values because all we have in this fraction is PQs and P plus Qs. So PQ, if I remember it, it's 5 over 2. I'll change the color. Right. 5 over 2 over 5 over 2 again, but squared this time, plus P plus Q was 2 squared minus 2 times PQ, which is 5 over 2, and then we have our plus 1. 5 over 2 over 5 over 2 whole thing squared is 25 over 4, plus 2 squared is 4 minus, the 2's cancel off, this and this, so we have a 5 and then a plus 1. So 5 over 2 over 25 over 4 plus 4 minus 5 plus 1. That gives 25 over 4. Let's simplify this further, which would give us 2 over 5. That's the product of roots. That's the value for product of roots. Now let's find sum of the roots. Which is going to be p over p squared plus 1 plus q over q squared plus 1. Now let's do the LCM again. So p times q squared plus 1 plus q times p squared plus 1 over p squared plus 1 times q squared plus 1. Let's simplify this further, and we get pq squared plus p plus qp squared plus q over, now we came across this denominator earlier as well, p squared plus 1 times q squared plus 1 under the product of roots. This one, it's the same thing. So we shall write the same denominator and later substitute in the value that we found. So we can write that as p squared plus 1 times q squared plus 1 equals. Now we can group pq squared and qp squared as 1 and p and q as 1, the additions. So pq squared plus qp squared plus, I'll put a bracket over this, plus p plus q. Now this seems a bit more familiar. Why? Because we know the value of p plus q, and if we look at pq squared plus qp squared, we can see that we can take pq outside. So we have a factor outside, and then inside we will have p plus q, which means again we know the values of pq and p plus q, so it will be easier for us to simplify the fraction. So again, the denominator, oh, that's a bad line. Okay, over p squared plus 1 times q squared plus 1. So I'll take the p and the q out. So pq squared divided by pq, 1p is gone, and from q squared 1q is gone, so all that's left is q plus, and then from qp squared 1q is gone, and from p squared 1p is gone, so just 1p is left, and then we have p plus q over our denominator, p squared plus 1 into q squared plus 1, and this is equals to pq is 5 over 2 times q plus p, or p plus q, which is 2, plus p plus q, that's 2, over this denominator that we found previously. This one, I'll change the color. In this denominator we directly found it as 25 over 4. There was nothing else added or subtracted in the denominator, so we can show the value is 25 over 4. So I'll substitute that in directly, less work, and we can see in the numerator the 2's cancel off, so we're left with 5 plus 2 in the numerator, which gives us 7 over 25 over 4. and if we simplify that, we get 28 over 25. So now that we've found the values of the summation and also the product of roots, we can directly substitute into the expression we wrote up here. This one. So x squared minus the sum, I'll rewrite that, minus the sum into x plus the product equals 0. X squared minus the sum, we found it to be 28 over 25. No minus there, so it's just 1 minus, plus product is 2 over 5. And now we simplify this to an expression where the coefficients of x squared and of the x and the constant are all integers and not fractions. So the common multiple is 25, so we multiply all the coefficients by 25. So 25 multiplied by x squared and 25 multiplied over here and 25 multiplied by here. So this gives 25 x squared minus, the 25's cancel off here, so we're left with minus 28x plus 25 divided by 5 gives us 5, so 5 times 2 is 10. Therefore 25x squared minus 28x plus 10 equals to 0 will be our answer to part B of this question. So we can finally maybe mention that where A is 25, B is minus 28, C is 10. And that's it. That's the end of question number 5. If you like this video, please like and subscribe the channel, and I'll see you soon.